Okay guys, continuing our series with the another lecture of logarithms, and today we're going to discuss about the problems. Okay, the first one here that I would love to discuss about is going to be log 10, 20, 10, 70. Now before doing that, I will tell you one important thing. For example, we have log base 2 1 by 2. We have log 1 by 2 base 2. Now what does it mean? I have to raise 2 something to in order to get 1 by 2. Now mathematically, if when I think about it, I am going to raise 2 to the power of minus 1. Think about it. If I raise 2 to the power of minus 1, I will definitely get 1 by 2, because taking the reciprocal of 2 to the minus 1, it becomes 1 upon 2. That is what actually is the right side. Now let me give one more. Log of 5, 1 upon 5. So again, it means what I need to raise 5 to in order to get 1 by 5. Now think about it. If I raise 5 to the power of minus 1, I'm going to get 1 by 5 again. So that means the answer here is 5 to the minus 1 equals to 1 by 5. So the answer for this particular problem is minus 1. I need to raise 5 to the power of minus 1 and I will get 1 by 5. So for this particular log problem, the answer will be minus 1. Now there's a pattern. What pattern is here? You can see that if the base and the argument here are reciprocal of each other, or multiplicative inverse of each other. So what are multiplicative inverse? Multiplicative inverse. Multiplicative inverse means if we have two numbers and we multiply them and the answer comes out to be 1. For example, here 5, and I'm going to multiply it with this. Base multiplied by this is 1 by 5. So these 5 cancels out. I'm left with 1. So you can see that when I multiply these two numbers together, the answer came out to be 1. Now it happens if it's a multiplicative inverse. Now in this case, 5 multiplied by 1 upon 5 came out to be 1. That means 5 and 1 upon 5 are multiplicative inverse of each other. Now what I'm saying here is, similarly, 2 multiplied by 1 upon 2 gives me 1. That means 2 and 1 by 2 are multiplicative inverses. Now why is that important? Because in case of logs, if this and this, if I multiply these two things together and it came out to be 1, then the answer will always be minus 1. Okay, so that is a pretty important conclusion. So if this, what I'm talking is the base and the argument itself, okay, are multiplicative inverse of each other, it means answer will always be minus 1. Now why is that important conclusion here? Let's dig into the problem. We have, we can remember this conclusion or we can do it logically. Doesn't matter how you're going to do it. Okay, let's see. Log 10, 20, log 10, 20, and we have 10, 70. 10, 70, okay? Now one thing that I'm going to do here is I'm going to replace this 10, 70 by, we have log base 10, 20, okay? 10, 70 can be written as 10, 90 minus 20 degrees, okay? Now, if we know from our some previous mathematical classes, we know that tan of 90 minus theta is cot of theta, I think, right? So it is cot of theta. Now we have tan of 90 minus 20, so it should be cot of 20, right? So here we have log of tan of 20 can be written as, this can be written as, I can replace this with cot, this becomes cot of 20 mathematically. Now, this cot of 20 again can be written as 1 upon tan of 20. So log of tan of 20, what I'm doing is, sorry, log of base of, log of cot of 20, base tan 20, okay. Okay, sorry, I wrote it again. So if I multiply these two together, just do it. If I multiply, this becomes tan of 20 multiplied by cot of 20. And cot of 20 can be written as tan of 20. This becomes tan of 20 into 1 upon tan of 20. Okay, now you can see that tan of 20 and tan of 20 cancels out. The answer comes out to be 1. That means here you can see that tan of 20 and cot of 20 are multiplicative inverses. And if they are multiplicative inverses, the answer should come out to be minus 1. So the answer for this particular problem is minus 1. Okay, let's keep moving. Let's move to the next problem. Okay, let's see how it goes. Okay, we have log of 10 of 0.9 bar. Log of 0.9 bar base 10. Now, before solving this problem, I need to worry about what this 0.9 bar actually is equal to, okay? Now, before doing that, I know that if I'm going to bring it out, 0.9 bar is a rational number. Because from some of my previous mathematical classes, you might have already studied that 0.9 bar is a number whose 9 is repeating here. So it's 0.9999 and 9. It goes like this. Now, if you're clever enough, you know that from our previous classes, we know that maybe in 10th or 9th, we already studied that 0.9 bar, I'm going to let it x for a second. So let it be x for a second. Now, if I do that, I need to worry how many numbers are repeating here. Now, I know that mathematically one number is repeating, that is 9 here. So it's actually 0.99. So only one number is repeating. Now, if one number is repeating, I need to multiply both sides of the equation by 10. Now, if it would have been two numbers repeating, then I need to multiply the numbers with 100. For example, it would have been 0.98 bar. Then it means 0.98, 98, 98 goes like this. That means for in that particular problem, I need to let that thing equal to x, and then I need to multiply that thing by 100. Now here, only one is repeating, one number is repeating. So that means multiplying both sides by 10. Now if I do that, what happens here? It becomes 10x equals to 9.9 bar. If I multiply right side by 10, it becomes 9.9 bar. Now what I need to do, subtract first from second. Now if I do that, call it first, call it second, doesn't matter. If I do that, 10x minus x is 9x. If I subtract the right sides as well, 9.9 bar minus 0.9 bar gives me 9. So that is x equals to 1. Now, if you're clever enough, you might say, wait a minute. How come 0.9 bar equals to 1? How can that be possible? Because here we are concerning about 0.9 bar is equal to 1. Is it mathematically true? I mean, at last, it came out to be that 0.9 bar is equal to 1. Now, you might be even a bit focused about it. Think about a number that's between 0.9 bar and 1. There won't be any, because if you can logically think about a number that's between 0.9 bar, it won't be there, because 0.9 bar means 0.999 and it goes like this toward infinity. Seriously talking about it, it does not stop at all. So 0.9 bar never stops. So you can't think even about a single number that lies between 0.9 bar and 1. That's why logically these two numbers are same. Okay? Now, this number came out to be 1. That means log of 10, and here actually we have 1. Now, what should I raise 10 to in order to get 1? What should I raise 10 to in order to get 1? I'm writing it in the exponential form. So I should raise 10 to the power of 0. So the answer here should be 0. Right? Okay, let's keep moving. Let's see another problem before going into it. If you want to write it down. Let's see. Now here comes a good looking problem. Maybe log of 5, root 5, root 5, root 5, all the way up to infinity. Now, when most people see this kind of problem, they feel scared and think, oh, maybe this is the most complicated problem that they have faced, but stuck with me for a second. Now, what I'm going to do here, I can see that this pattern repeats, root 5, and goes up to infinity. I'm going to call this whole thing as y for a second. Now, if I call this root 5, blah, blah, this is equal to y for a second, let. Now, if you are clever enough to say that, I call this y equals to root 5, root 5 goes like this. Now, if I start from my numbers from here to infinity, it's still y. Now, what I'm saying is, if I'm going to do it like this, y is equal to 5, okay? I'm writing this 5 here, but I know that 5, root 5 goes like this. But if I start my numbers from here, still it is y, because it goes up to infinity. So from here, I can consider it is also y. So I can say that this is 5 multiplied by y. Because this actually is also written root 5, root 5, root 5, and I consider root 5, root 5, root 5 as y. So I'm writing this whole thing as y. Why? Because this 5 has been written and this whole thing is y actually, as I let it to be y for a second. Now, how can it help me out? I know that squaring both sides, that's the only possibility that I can do here. This becomes y square equals to 5y. That becomes a quadratic. Bringing this on the other side, this becomes y square minus 5y equals to 0. We have two numbers here. So this becomes taking y common, y minus 5 equals to 0. Now, either y has to be 0 or y minus 5 has to be 0. That means y should be 0 or y is mathematically 5. So we got two numbers here, y being 0 or 5. But y is actually this whole thing, and you can seriously check it out that this can't be 0, because if y is this whole bigger thing, it can't be 0 because it's a positive number. It should be a positive number, so it can't be 0. So it should be 5 because we have root of positive numbers, and it cannot be 0. This whole thing cannot appear to be 0 later on because I consider y to be this thing. So that means it has to be 5. So y equals 0 should be neglected, and y equals 5 should be considered. So it becomes log base 5. This whole thing came out to be 5. This came out to be 0 and 5, but I neglected it to be 0 because it can't be 0, because I'm taking square roots of positive numbers. It can never be 0. It will come out to be a number, and it will come out to be a positive number. So that's why I neglected 0 and took 5. So what should I raise 5 to in order to get 5? I should raise it to the power of 1. So again, the answer is 1. Hope you understood.